Hello. In this video, we are going to see about the state description. We are going to solve two problems. The first problem is in a sequential system has one input with the values a, b and c, small a, small b and c. Okay, and one output with values p and q. Right. So the sequence system is having one input which can be either a, one of the values. It can be a, b or c. And similarly it has only one output whose values can be p and q. The question is output is q. Output can take two values p and q. Here they are saying output is q whenever the input sequence has even number of a's and an odd numbers of b's. Okay, the input should have a sequence which is having even numbers of a and odd numbers of b. Then output is q. Okay, they are asking obtain the state description of the given system. Right. So it's very clear. What is the input? We are going to the solution. The solution start with what are the inputs? Input is x. What are the values of x? X can be either a, b or c. Okay, what is the output? Output I am taking it as z. Z can take the values. Z belongs to p or q. Okay, then what is the function? Output z is equal to q. Look at this statement. Output is q whenever the input sequence has even numbers of a and an odd numbers of b. Right. So output z of t is equal to q if number of a's is even and number of b's is odd in 0 to t minus 1. Look at the time. Output I am taking at the time t. Okay, so before time t, what is the meaning? T minus 1. So 0 to t minus 1, that is before the time t. Okay, so what is that? If I say this is the time, okay, we are here, the time t. This is the time t, right? What is before time t? This is 0, time 0. Okay, so before this is your t minus 1. Okay, this entire time stretch, that is before time t, that is 0 to t minus 1, you should have number of a's as even, number of b's should be odd at the inputs. Then the output is z of t is q, otherwise it is p. Okay, because output can take only two values, either p or q. When output is q whenever the input sequence, that is the x, has an even numbers of a and an odd numbers of b. Okay, otherwise the output is p. Okay, here we are going to take the state as, since it depends on two inputs a and b, we are going to the state as sa of t comma sb of t. Okay, what is sa of t? It is the number of a's mod 2. What is sb of t? Number of b's mod 2. Okay, what is number of a's mod 2? What is the meaning? Number of a's means how many a's, how many a. Okay, how many a are coming to the input, or coming as input x. Okay, coming as input x of t. Right. Suppose what you are doing, number of a's, let me say number of a's is equal to number of a's is 4. 4 a's are coming, okay, at the input. So what happens? 4 mod 2. Mod gives the remainder. Okay, so 4 modulus 2, mod operation 2 gives remainder as 0. So your SA of t is 0. Suppose number of a is 7. 7 a's are coming, okay, the input. If 7 mod 2, what is the remainder? Okay, 3 times you can divide, so we get 6. Remainder is 1. Mod gives the remainder, so SA of t is equal to 1 now. Okay, similarly I can extend this idea for b. Number of b is equal to mod 2. Okay, so it's very simple. When the number of a or number of b is an even number, okay, SA of t or SB of t is equal to 0, when the number of A's or number of B is an odd number, SA of t or SB of t is equal to 1. This is used to identify, remember, this is used to identify whether an even numbers of A or odd numbers of A. Because the question is clearly given, output Z of t is equal to Q, Z of t is equal to Q only when number of A is even and number of B is odd. Okay, so number of A should be even, number of B should be odd, right? So number of A should be even, number of B should be odd. If it is even, SA of t is 0. If number of B is odd, SB of t is 1. Okay, so 0, 1. 0, 1, for that the output is Q. Okay, for that state output is Q, right? Initially we are starting from the state, we are saying both as 0, both the state as 0. Okay, then transition, right? If the next input is A, right? See, this is the t is the present. Okay, let me clarify here few words. SA of t is the present state, SA of t plus 1 is the next state. Similarly, SB of t is the present state. Okay, SB of t plus 1 is the next state, right? Okay, so what is happening is, whenever new A is coming, what happens? An even number is converted to odd number. Okay, suppose you are having 4 A's already, next input is A, so it becomes 5. That is, the past state will be keep on toggling. SA of t will become SAT dash. This is nothing but complement. The previous value will be complemented. Okay, you can clearly see, right? Initially number of A is equal to 4 A's are coming, so 4 mod 2 is 0. Next also A, so what happens? 5 mod 2 is 1. Okay, next input is also A, so what happens? 6 mod 2 is 0. So 0 and 1, whenever A is coming one after the other, the SA of t will become complement of the previous one. Okay, that is SA of t plus 1 is equal to SAT complement. Otherwise, if it is not equal to A, it is the same value, SA of t. Okay, the same thing I can say for SB of t plus 1, right? If X of t is equal to B, right? When the new value is B, what happens? An even sequence, when another number is coming, it becomes odd. Okay, when another B is coming, odd becomes even. Thereby SB of t will be keep on complementing zeros and ones. Okay, SB of t otherwise. Okay, now as I said earlier, what is the output? Z of t is equal to Q if the state is equal to 0, 1. Actually, what is the meaning of this 0, 1? This 0 stands for SA of t. This 1 stands for SB of t. Okay, when we will have a 0, you can come to the expression here. Yes, you can see here. 1 minute, yeah. What is SA of t? When the number of A mod 2, SB number of B is mod 2. If number of A is an even number mod 2, any even number we do mod 2 operation, you will get the remainder as 0. So SA of t is 0. Similarly, number of B should be an odd number, because this is what given in the question, right? Look at the question. Output Z of t is equal to Q. Output is Q whenever the input sequence has even numbers of A and an odd numbers of B. Okay, so even numbers of A means what happens? Even numbers of A means A is an even number, even numbers of A's are present, even numbers of A mod 2, it is 0, SA of t is 0. Similarly, number of B's, right, it's an odd number, any odd number do mod 2 operation, the remainder is 1. Okay, so SA of t is 0, SB of t is 1. Okay, when this condition is satisfied, Z of t is equal to Q. Okay, that is what written here. Z of t is equal to Q if S of t is equal to 0, 1. Otherwise, output can take two values. Z of t is equal to Q for this condition. That is, A is an even number of B should be an odd. That is, the state should be 0, 1. Otherwise, it is P. Okay, now we go into the state transition table, right? So we have two states, we have two variables, that is your SA and SB. Okay, so four possibilities: 0, 0, 0, 1, 1, 0, 1, 1. So remember, the first one is your SA of t, that is the present state. This is your SB of t. Now, based on the inputs, what are the inputs possibility? A, B and C. A, B and C, right? So we know the condition, we are going to fill the next state and the next state here. Okay, right. What is the meaning? 0, 0 means, what is the meaning? Both are even numbers. Even numbers of zeros, even numbers of A, even numbers of B. Okay, yes, look at the condition. Yes, you can see. Where number of A is an even number, even mod 2, answer is 0. Number of B is an even number, even mod 2, answer is 0. Okay, so the present state, both for this condition, both A and B are even numbers. Now what is the input is coming? Input coming is A. So what happens? Even numbers of A, one another new A is coming, it is converted to odd number. So odd numbers of A mod 2, what happens? Odd numbers of A mod 2, answer is 1. Answer is 1. And of course, B won't change. Okay, next, if the input is B, what happens? What is the B? It's an even numbers of zeros. Even numbers of B, even numbers of B, so we get as 0. Okay, new B is coming, so even becomes odd. Odd means B becomes 1. Okay, suppose we are getting an input C. It is not going to affect both A and B. It is still, both are even numbers, it will retain the same thing. Okay, now look at this. Okay, once you see few examples, you can understand. Okay, look at this. 0, 1. What is the meaning? This 0 stands for SA of t. This 1 stands for SB of t. Okay, right. So this 0 indicates it is an even numbers of A. 1 indicates odd numbers of B. Okay, right. Now new A is coming. One new A is coming. What happens? This 0 is an even number. Another A is coming. It converts to odd number. Odd number, you take mod operation. You will get answer as 1. You will get the answer as 1. Okay. So your B will not be disturbed because the input is only A. We are solving for A. Next, when the input is B, A will not be disturbed. Now if you see here, initially B is an odd number, another B is coming, so it becomes an even number. Even numbers of B, you take mod 2, the answer is 0. Next, when the input is C, it is not going to affect the value of both A and B. Okay, it is still even and this is still even and odd. Okay, right. Now come to this case. What about this one? The first number, this number is your odd numbers of A, even numbers of B. 0 stands for even number, 1 stands for odd number. Now when the input is A, already odd numbers of A is the present state. What is the next state? Right? When the input is A, odd number is converted to even number. Even number you take mod 2, you will get the answer as 0. Now input is B. What does this 0 indicates? Even numbers of 0, another B is coming, so it becomes odd number, so B becomes 1. Odd numbers mod 2 is 0. Here A is not affected. Once B is coming, A is not affected. Okay. Now C is coming. Both A and B will not be affected. 1, 0. The same as it is. Okay. Now come to the last row. What is the condition about this? Yes, you can say, you can try it. Check it out. What does this indicates? This 1 indicates, what does this 1 indicates? Odd numbers of A. This 1 indicates odd numbers of B. Now the input is A. So odd numbers of A, another one A is coming, so it becomes even numbers of A. Even numbers of A take mod operation, it becomes 0. So B is not affected because we are dealing only with A as input. Next, input is B. Okay, so A is not affected. A is not affected. A is not affected. And see here, when the input is B, what happens? 1 becomes, think about it, when the input is B, already we have odd numbers of B. Okay, odd numbers of B, it's 1. Another 1 is coming, it becomes even number, it becomes 0. Okay, next, when the input is C, what happens? Both are, this is A, this is B. Now the input is C. Their count is not good, numbers is not going to get affected. So it is still 1, 1. Right? So these are the next states. This entire thing which you have filled now is the next state. Okay, now what is the output? I can fill the output here. Output depends only on, you can clearly see from the expression, for the present state 0, 1, output is Q. For all other cases it is P. So 0, 1 is here. 0, 1 is here. Okay, for this the output is Q. Okay, for all others it is P. Right? So this is the state table for the given question. Okay, this is the output Z, I can say. This is the output Z. Now we move into the state diagram. Right? So state diagram means it's very simple. We have to convert the table to the diagram. Right? How many states are there? 4 states are there. That is 0, 0 is one state. Okay, corresponding 0, 0, output is P. Remember, it is a Murray circuit where output depends only on the state. Okay, output P or Q depends only on the state, not on the input. Okay, what are the other states? 0, 1. 0, 1. It is Q. Then we have the state 1, 0. It is P. Then we have 1, 1. State, it corresponds to P. 1, 1 corresponds to P. Okay. Now what is the, you can check it out. We are in the state 0, 0. When the input is A, we go to the state 1, 0. We go to the state 1, 0. When the input is A. Similarly, when the input is B, we go to the state 0, 1. When the input is C, from the present state 0, 0, we go to the same state. Okay, right? Similarly, you can fill for others one. We are in the state 0, 1. When the input is A, we go to the state 1, 1. Similarly, when the input is B, we go to the state, see, when we are in this input is B, we are in the state 0, 1, we go to the state 0, 0. When the input is C, okay, we go to the state, same state. You are in the state 0, 1, you go back to the state, same state 0, 1. Okay, similarly, you can fill others, right? You can pause the video and you can fill it. This is your C, this is your C, this is your E. So this is the state diagram. Okay, right? So this problem is done. Now moving to the next problem. It's a very easy problem. A sequential circuit has 1 decimal digit as input, radix 5 digit as the output. The value of the output at time t corresponds to the sum modulo 5 of the input digit from time 0 to t. Obtain the state description. Okay, so it's from the question. We can go into the, now we move to the solution. Okay, what is the input? Input is decimal. Okay, input is decimal. What is a decimal number? Decimal digit we know very well. It belongs to 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's a decimal. What is the output? output is, I am taking it as Z. Z they have clearly given it is a radix 5. What is a radix 5 meaning? Radix 5 means it is 0 to 4. That is the radix 5. Okay, and what is the function? Look at this. The function, what they are saying is the value of the output, that is Z, it corresponds to sum of modulo 5 of the input digits from 0 to t. Okay, this statement you have to understand, right? So what they are saying is output Z of t is equal to summation of input. Okay, they are saying, let me take the input. I have not given the variable name. Input is x of t. Okay, input is x of I, temporary variable I am giving as I. What is the range of I to t? Look at it here. It is the value of output at time t corresponds to sum of modulo 5 of the input digits. What is the input? X of t. What time they are taking? 0 to t. So input from 0 to t I am keep on adding. That is, if I need the output at time t, I need to add all the previous inputs of x, and I have to take what operation? Mod 5 operation. If I take mod 5 only, the remainder will be 0, 0, remainder will be between 0, 1, 2 or 4. One among these values. That's why we take mod 5. Mod 5 gives the remainder. Okay, right. So this is your function. This is your function. Function is nothing but, see this for this statement I have written the mathematical equation. That's it. That's the function. Okay, right. So what are the states? So the states I can take it as states S of t belongs to 0, 1, 2, 3, 4. That's the state. Initial state, that is initial state I am starting from 0. Okay, then what is the relation between the present state and the next state? Okay, the present state and the next state, the relation is, if I say next state, that is your S of t plus 1 is equal to present state plus x of t. Right, what is happening? We are keep on adding. Right? So past value plus the input mod 5. That is the next state value, as well as what is the Z of t? Z of t is equal to the same thing, S of t plus x of t. This is mod 5. Okay, right? Okay, is it okay? So this is what we can say, this is called state transition and output function. This is called state transition. State transition. What is state transition? From the state S of t, present state to next state, how it is transiting, changing, and this is called output function. We have described this in equation. Okay, right? So the important thing is we have to understand the question, then we have to write the function, then we have to write the transition function. Okay, here we have taken the outputs and the states as the same. So here of course we are getting the same equation for both the state transition and the output function. Okay, right. Thanks for listening. Happy learning.